Good morning, chemistry students. Here are some notes on Chapter 8, Section 2 about double replacement reactions. As a means of review, remember so far we have talked about combination or synthesis reactions, decomposition reactions, and single replacement reactions. Really quickly reviewing those. A combination reaction. How do we know that we have a combination reaction? We have two or more reactants and a single product. How do we know that we have a decomposition reaction? We have a single reactant and more than one product. Remember, for combination and decomposition reactions, it's fairly hard for you as new chemistry students to predict the products. So typically you won't be asked to do so unless it involves ionic compounds decomposing into their elements or a metal and a non-metal combining to form a single compound. The third type of reaction were the single replacement reactions. Remember, to identify a single replacement reaction, we have two reactants. It's always an element and a compound. And our products are two products, always an element and a compound. Remember that the element that is by itself in the reactant has to be stronger than the same type of element in the compound for the reaction to take place. If that element is not stronger, you're going to write no reaction. How do you know if that element is stronger? Remember, that's where you're using your activity series of metals and group 17 or 7A, the halogens. On both of those, at the top are the strong elements and towards the bottom are the weak. So, focusing today on double replacement reactions. We're going to start with the definition of what a double replacement, also sometimes called a double displacement, reaction is. And again, I give you both names just so that in case at some point in the future you have a chemistry class and they use a different term than what we're using today. Double replacement or double displacement reactions involve an exchange of positive ions between reacting compounds. Now, we did already see some double replacement reactions also on the ChemQuest that you have done so far. As always, we're going to move into then, what do I see for my reactants for double replacement reactions and what do I see for my products? Focusing first on the reactants. Again, if we look at our definition, it gives us a clue, right? It tells us that these reactions involve an exchange of positive ions between reacting compounds, okay? So that means in terms of reactants, okay, that we have to have two, so they're always two, and it's always two compounds. Okay, so our reactants for double replacement reaction, there's always two of them, and they're always two compounds. In terms of our products, we also always have two products. And again, they're going to be two compounds. They won't be the same compounds. They won't be the same because, again, we've had that exchange of positive ions, okay? But we're still going to have two products and they're always compounds. So again, idea being, if I'm looking at a bunch of chemical equations, and I'm asked to identify which ones are double replacement reaction, I'm going to look for reactions that have two reactants, and both of those reactants are compounds. For double replacement reactions, you must be able to predict the products. And we're going to talk about our dating or our dance example. So we'll kind of place it at a dance, and trying to think of some people that we have in class. So let's say that we have Ian dancing with Phoebe. And we also have Poom dancing with Leticia. Okay, so these are our reactants, right? Again, we have two compounds. We have some boys dancing with some girls, okay? So throughout this dance, as they're dancing, Ian has decided that perhaps he doesn't want to dance with Phoebe anymore, and he'd really like to dance with Leticia. And as a result, that means that Poom is going to have to dance with Phoebe. So our products are Ian dancing with Leticia and Poom dancing with Phoebe. Okay, so again, our products here, we still have two compounds, okay, because we have Ian and Leticia, Poom and Phoebe, but notice that they are different compounds than what we started with. Most common mistake is that we put two of the same together, okay? So for double replacement reactions usually take place between ionic compounds. Remember, we know something's an ionic compound because it's made of a metal and a nonmetal, or it contains a polyatomic ion. So double replacement reactions usually take place between ionic compounds dissolved in water. This is called being in aqueous solution. So having ionic compounds dissolved in water is called aqueous solution. And double replacement reactions usually take place between these ionic compounds dissolved in water. So these reactions usually take place in aqueous solution. Okay? Most double replacement reactions, okay, so usually double replacement reactions are going to form a precipitate. Precipitate is a solid that is not soluble in solution. So again, the definition of precipitate is it's just a solid that forms. Okay, because again, typically in a double replacement reaction, we have two ionic compounds that are dissolved in water, and so when we mix them, we get a precipitate or a solid that forms. Now, oftentimes double replacement reactions form a precipitate. However, they have to have something happen. So something must happen so we know that the reaction has taken place. Oftentimes, that's going to be this precipitate, but it could be one of three other things. Okay, so we must have, right, the solid produced, which is our precipitate. Okay. A gas. Now, it's kind of silly to think about, but you probably all enjoyed it at some point in the past. When you were a little kid and you used to take baths, you thought it was funny when you passed gas in the bathtub because you made bubbles. Okay, so you're going to know that there's a gas if there are bubbles produced. Because again, these are solutions that are dissolved in water. Or you produce a molecular compound. Remember, a molecular compound is made of two nonmetals. Okay? The most common molecular compound in these reactions is water. Okay? So, for a double replacement reaction to take place, because again we have these two ionic compounds dissolved in water, these two ionic compounds in aqueous solution, something has to happen when I mix them together so that I know this reaction has taken place. One of those, there's kind of three things that can happen. Most commonly, we have a solid produced, or that precipitate. Okay, that's what happens most often. However, we also could have bubbles produced, which tells us we've produced a gas, or we have a molecular compound. One of those three things has to take place so that we know that a double replacement reaction has taken place. So, moving on to our example. Again, we're going to start with our sentence. So we have sodium sulfide reacts with cadmium 2 nitrate. Now, again, you'll notice I've only given you reactants because you have to be able to predict the products. So before we even start writing our word equation, remember our word equation only symbols are plus signs and arrows. Before we start to write our word equation, remember our definition of double replacement reactions. There's an exchange of positive ions. So we want to figure out who are the positively charged ions here. Remember, positive ions are our metals. So sodium and cadmium 2, they are going to swap places. So that will help us when we're trying to write our word equation. So our word equation is going to start with sodium sulfide reacts with becomes a plus, cadmium 2 nitrate, our arrow. Now, sodium has swapped partners. So sodium's partner isn't sulfide anymore. Now its partner is nitrate. Cadmium is still going to be cadmium 2. But its partner isn't nitrate anymore. Its partner is now sulfide. Because again, we've had that exchange of positive ions, that exchange of the metals. So now that we have a word equation, now we're ready to write our skeleton equation. Now we're going to take everything, we're going to make it symbols. These are all ionic compounds because they all contain metals. So every single time I'm going to do symbols, charges, crisscross, lowest whole number ratio. So I have Na, charge of +1, S, -2. So I need to write this as Na2S plus Cd +2 NO3 -1, crisscross down, I needed 2. Sodium is Na, nitrate is NO3 -1, nothing to do to that one. Cadmium is Cd +2, sulfide is S -2, nothing to do to that one. So I currently have my skeleton equation. Now I'm ready to balance. I have 2 sodiums here. I have 1 sodium, so I need a coefficient of 2. I have 1 sulfur. I have 1 sulfur. That's fine. 1 cadmium. I have 1 cadmium. That's fine. I have 2 nitrates and I have 2 nitrates. So I think it's balanced. I'm going to check it. Okay. So I have 2 sodiums, 1 sulfur, 1 sulfur, 1 cadmium, 1 cadmium, 2 nitrates, 2 nitrates. This is properly balanced. So double replacement reactions. Okay, again, I'm going to know I have a double replacement reaction because I have 2 compounds reacting, producing 2 compounds. They're different compounds, but they're compounds. Okay. To predict the products, always my positive ions are swapping spots. Okay, so that sodium ends up with a new partner in this example, and cadmium 2 ends up with a new partner. So that's what you need to know about double replacement reactions. Your homework is on page 224, number 24, which asks you what 3 types of products drive double replacement reactions. So what that's asking is, what has to happen for you to know that a double replacement reaction has taken place? Thank you. Have a great day. Talk to you tomorrow.